Hi there, this is Middle School Math with Dr. Koenig, and I'm glad you're here. Today we're going to talk about calculating slope given 2 points on any line. So there are 3 major ways to find slope. You can find it from a graph of a line, you can calculate it from a table of values, and you can find it from 2 points on the line. Obviously today we're focusing on if I have 2 points on a line, how do I know what the slope is? However, if you need help with the other 2 skills, I'm going to drop 2 other videos that I have here so you have access to them. Otherwise, let's jump right in. All right, so there is a slope formula, but it's important to understand where the slope formula comes from, what it means. So I wanted to take a look at 2 points on a graph. So before we take away the graph, before we talk about a formula, what are we finding when we're finding slope? So let's imagine there was a line through these 2 points and we're trying to find the slope of this line. If you know a little bit about slope, you know that the slope tells you the change in y for each value of x. So we would calculate the slope on a graph by looking at how much that y changes and how much the x changes in the same amount of time. So for example, the y value increases by 5. The x value increases by 3. So my slope is 5/3. Now there is a formula that does the exact same thing for you, and it's this formula here. It's y2 minus y1 over x2 minus x1. It's essentially saying I can take the values of one of my points, remember each point comes with an x and a y, and I could subtract it from the values of the other point, and this formula is what will tell you the slope. So let's take a look at some examples of this. Here we're given a line that crosses through the point 3, -4, and -520. According to that formula, we can take y2 minus y1, and we could put it over x2 minus x1. So what does that mean in the context of this problem? Well, remember, each point comes with an x and a y. So I'm going to call my first point x1 and y1, and I'm going to call my second point x2 and y2. Those subscripts are there to differentiate the 2 points. It doesn't mean that we're going to square any values or use exponents. They're just subscripts. They tell us that there's a difference between x1 and x2, and there's a difference between y1 and y2. So if I plug those into my formula says to take y2, which is 20, and to subtract y1, which is -4. And then on the bottom it says to take x2, -5, and subtract x1, which is -3. Now, there's a whole lot of negatives happening in here, so let's take a look at how we could simplify this problem. Now, if you remember from previous math lessons, you can rewrite something that is subtracting a negative. If I'm subtracting a -4, I can add the inverse, the additive inverse, so I can change it to 20 plus +4. The same is true on the bottom. The -5 has to stay the same, but I can change it to -5 plus a +3. If I simplify that numerator, I get 24, and on the denominator, I get -2, which again simplifies to give me -12. That tells me that this is a pretty steep line with a slope of -12. Here's another example. Again, I've got 2 points, so I'm going to call them x1 and y1, x2 and y2. And remember that the equation says I take y2 and I subtract y1, and I take x2 and subtract x1, and when I put it all together, I get the slope. So in this case, my y2 is -4, and I'm going to subtract -13. It's important to notice that the equation has subtraction signs. So if these values on the right-hand side are negatives, we're subtracting a negative. And sometimes all of those negatives and minus signs can get a little mixed up and confused. So that's just something to really tune into. On the bottom, I have x2, which is 3, minus x1, which is 15. Again, I'm going to rewrite this so I know that I can take -4 and I can add the additive inverse, which is +13. On the bottom, if I really wanted to, I could still change that. I could change it to adding the additive inverse, which is -15. When I simplify my numerator, I get 9, and my denominator gives me -12, which isn't as pretty as the last example. However, in this case, if I divide both by 3, I get my slope, which is -3/4. Let's do 2 more examples just to really get a feel for this formula because it is really messy. So remember, the formula is y2 minus y1 over x2 minus x1. And remember, those subscripts, they're not doing anything. We're not squaring any values or anything like that. It just differentiates the fact that we have 2 points that both have an x and a y coordinate. So it's important to know that the x1 and the y1 are together as a coordinate, and the x2 and the y2 are together as a coordinate as well. So here we have y2 as 2, and again, we are subtracting a negative, so make sure none of those minus signs or negatives get lost along the way. And then -4 minus -19. I will simplify my equation before I solve. So I see that I can add the additive inverse 4, and here I can add the additive inverse 19. When I put all that together, I get 6 in the numerator and I get 15 in the denominator. So again, we've got a fraction. It's not going to divide to a nice whole number slope or integer slope, but it does simplify. When I divide by 3 in both the numerator and the denominator, I get a slope of 2 over 5. All right, one last example just to make sure that we have solidified this formula and how to use it. So I'm going to rewrite my formula and circle it. That just kind of helps us focus on what we're doing. Remember that each point has an x1 or an x and a y, so x1, y1 go together. x2, y2 go together as well. Now when I plug these into the formula, what I notice is that my y2 and my y1 are the same, which means something about the value that I'm going to get. Now, when I subtract 2 minus 2, of course, I get 0, and 3 minus 11, I get -8. So we need to think about what happens when we divide a 0. In this case, if I have 0 items and I split them into 8 groups, or -8 groups, as this example shows, I can't split 0 items up. I still have 0 items. That means my slope is 0. 0 divided by anything, of course, is 0. Now, what does that mean on a line? So if I graph this and I see a 0 slope, that means this line is flat. It has no slope at all. It's not increasing. Even though the x values are changing, the x values are decreasing, the y value is not changing, which gives us a slope of 0 on a horizontal line. All right, so the big understanding, the big takeaway from this video is that there is a slope formula, and that slope formula can help us if we're given 2 points, find the slope of the line that those 2 points are on. Now, what it's really telling us is that we're comparing the y values to the x values, and we're looking to see how the change in y compares to the change in x. However, it does so using a formula. Now remember that x2 and y2 go together for 1 point, and x1 and y1 go together for another point. So we're subtracting 1 point from another point. Also, it's important to remember that these are subscripts, so we're not squaring anything, we're not using any exponents, we're just differentiating 1 point from the next. Now, I hope this helps you to better understand how to find the slope given 2 points on a line. If you need help finding the slope from a graph or from a table, remember, I've got some videos that can help you out. Otherwise, this should give you a good start on finding that slope. Thanks for being here, and I'll see you next time.